here is an earthquake. We're going to talk about the Richter scale. It says, the intensity I of the 1906 San Francisco earthquake was approximately 50,118,000 I naught. Okay, that little I sub 0 means I naught. It means that it's the I naught is like the earthquake that you can barely feel. So you'll have to talk to your instructor more about that. But given that information, it says find the Richter scale magnitude of this quake. Well, basically you're given the formula here. Here it is. Magnitude is equal to log base 10 of I over I naught. Okay. Now you're given in the problem the value of I, and that is your 50,118,000 I naught. And just following the formula, if you divide by I naught, okay, the I naughts cancel, and basically you're left with log of 50,118,000. Now, with that said, just take your calculator out. This is a log base 10. You put it in your calculator, and what do you get, Charlie? We'll round to the nearest tenth. 7.7. That's right, 7.7. So it was a 7.7 magnitude earthquake on the Richter scale. Okay. Now, we're going to do a chemistry problem here. Okay? So pay attention to this one. Now, Charlie, here we go. If the molarity of the hydrogen ion concentration in a solution is 3.45 times 10 to the negative fifth, find the pH. Okay? That's what we're going to do, Charlie. Of course, we got to go to our formula. Well, pH is equal to the negative log of the hydrogen ion concentration. Okay? Now, for those of you that are in chemistry right now, remember, hydrogen ion concentration is often used because it's more compact or easier to write than the hydronium ion concentration, which is up there. So they're the same thing. You should talk to your chemistry professor about this notation. But often, hydrogen ion concentration is used to replace hydronium ion concentration. Same thing, but talk to your chemistry professor. Now, here's a simple problem. We're calculating pH, and we have the negative log, and our hydrogen ion concentration was given to be 3.45 times 10 to the negative fifth. And we'll go ahead and write it, take it out of scientific notation, and notice we have 0.0000345. And again, you take the logarithm of that number. Remember, it's a base 10 logarithm. And then what do you get for that logarithm, Charlie?
Negative 4.46218.
Negative 4.46218. Very nice. Okay. Now, with that said, Charlie, remember, what's the opposite of negative 4.46218? Positive 4.462. Notice here we're rounding to the nearest thousands. Now, that's because generally in chemistry, you have to worry about significant figures. And the way this works is you look at your given information. Now, we were given that the hydrogen ion concentration was 3.45 times 10 to the negative fifth. Now, that's 3 significant figures there. Okay? Well, when you do a logarithm calculation with 3 significant figures, your answer must have 3 decimal places. Okay? So, if we have 3 significant figures, notice our answer here has 3 decimal places. And that's the rule for significant figures, generally in any chemistry class, okay? And so that completes our lecture on some logarithm applications. Remember, we used the change of base rule a little bit, and then we did some calculations. Now, in our next video, we're going to do some chemistry problems where we have to worry about significant figures. We're going to talk about hydrogen ion concentration and hydroxide ion concentration, and some other things. So anyway, we hope to see you back soon. Anyway, get to work, Charlie. Do your homework.